Hello everyone, welcome to ARM through C, where we learn the assembly language by decompiling C code. Made it. In this episode, we're going to look at assignments and 4 basic mathematical operations: addition, subtraction, multiplication, and division, and how they are translated from C to the assembly language. And we'll jump right into it. Just want to show you the board we'll be working on. This is a Nucleo board featuring an SM32F4 something microcontroller that uses an M4 architecture, but let's not worry about that at the moment. The second and probably the last tool that we'll be using is the STM32Cube IDE, which is an integrated development environment using the GNU compiler for ARM. And I've already partitioned it into an editor, a disassembly window where we'll see our disassembled code, and the register window. Now with the register window, we'll be able to see the general purpose and some other registers present in ARM architecture. What are registers, you might ask? Well, they're just small pieces of memory inside the core on which the core can do mathematical manipulations and uses them for data transfer. Because now that we're leaving the comfortable abstractions of variables and scopes, you have to be aware that the ARM architecture has 3 types of memory: the flash memory, from where the program is run, the random access memory, where you store data, but you're not free to manipulate data in RAM directly. You can do it only through the registers. So we have this handful of general purpose and other registers that help you manipulate and transfer data. Okay, let's dig in with the first example. Everything will happen in main. We'll just ignore all the rest for the moment to avoid unnecessary complexity. So we have a main function, and within this main function I just declare 6 integers unsigned, and in a while one loop, they're in a while one loop so that maybe I can iterate more than one time without recompiling or restarting the debugger. So within the while one loop we have 2 assignments: A equals 6 and B equals 2. And following that, we have just 4 mathematical operations, 4 equations stored into 4 different variables declared previously. So finally, we're ready to press debug and see the compiler digest our C code and see what gets presented in the disassembly window. And here it is. We can see right away that the assembly code is not everything that's presented here. The assembly code is actually in green, but we also have all the C lines in between, so we can clearly see into what instructions each line is translated. And we also have labels that coincide with the function names, so we can more easily follow the flow of the program in the disassembly window. And for now, we'll just ignore the first 3 lines inside main, because they are just some memory manipulations that we'll see later in the later examples, that basically just reserve 20 bytes for the local variables to live within the memory, within the stack, and they later reference each memory position in relation to the value stored in the R7 register. So we'll just start with the first assignment with a equals 6. And here is our first assembly instruction. This is a move instruction that moves the value 6, also called an immediate value, inside of register R3. Now there's also an S beside move, which just means that another register gets changed, but we can ignore it for the moment. And following that, there's a store operation, which moves data from the register inside the memory at some address defined as the sum of these two values. So the value in R7 and some fixed offset. And if I advance just one C line, I can see that it advances 2 lines inside the assembly window. So one assignment is actually 2 instructions. Now for this simple example, because we're obviously going to sum 2 registers, 2 values, you might ask, why is each value stored in some memory location? Why can't we just load one value into register X, another value into register Y, and sum them up or whatever in a third register? Well, the compiler does it for consistency, because it cannot in general know how many, well, it could, but it's easier this way. It cannot generally know in advance how many variables we'll have, and we only have a very limited number of registers. So the general idea is to store everything in memory and then call it back when it's needed, because the memory is just so much larger than the very limited general purpose instructions registers. Okay, so we do the same for the second variable. It loads the number 2 into the same register that gets overwritten, but the value 6 is already saved in memory. And then it saves the second value into another location in memory, which is coincidentally 2 bytes, has a 2-byte offset from the previous one, which corresponds to the width of the variable type. So they will be neatly packed one after the other inside the stack. We can also note in the register window that now only R3 contains a value of 2, which is the last value saved into that register, because the value 6 got overwritten the second time around, but all the values are safely stored inside memory. And now we have our first computation, which is a summation. And let's try to figure out in advance what will happen. So first, we will fetch with the instruction load, which loads a value from memory into a register. With this instruction, we'll load the value which is at offset 14, which will be the 6 that was saved into that location. So it will load that value, it will load the value 6 into the register R2, and then it will do the same for the number 2, which is stored at the offset of 12 bytes, into the register R3. And then it will add those 2 values with a very descriptive name for an instruction, just add. And it will save the value into R3. So R3 will get overwritten with the sum, and then it will store that value at the summation result into another memory location. Okay, now let's just advance one more C line, and after the summation we see that R2 contains the number 6 and R3 contains the sum. And now we could do the same for the other 3 operations, but this video is actually getting too long as it is. But we can notice that for each operation it will do, the first 2 steps will be the same. It will just load A and B into registers 2 and 3. And after the operation, it will store the result at some location from register 3. And in between, it will actually do the operation. It will do a subtraction, so save to R3 the difference between R2 and R3, a multiplication with this instruction, which is a variation of the multiplication instruction, and so multiply R3 by R2 and save it into R3, and similar for the division. And once we'll reach the end, it will, this is a branch instruction, an unconditional branch, and here it says, look, go to this address, and let's check out what's this address. It ends with 1DA, and this is just our first assignment. So it will go at the beginning of the while loop, and it will do this over and over again. So, alright, so this was the first ARM through C tutorial. I hope it was instructive to you, because otherwise it was a waste of time for me. But hey, what else can you do on a Saturday night, right?